Hi, welcome to iFlip for Math, Mathcast, Lesson 4-2, Estimating Quotients. I'm Mrs. Gooding, and our quote tonight is from Bram Stoker. He was the author of Dracula, which was written a long time ago. You can see that old movie poster there too. We learn from failure, not from success. I like that quote a lot. Mathematicians a lot of times find the right answer after finding the wrong answer a lot of times. Our learning goal today is to use rounding and compatible numbers to estimate quotients. We have done that with products. We're just using them now to estimate quotients. Here are our individual lesson learning goals. We're going to use basic multiplication facts to generate compatible numbers. You've done that. You're also going to use mental math to divide compatible numbers by single-digit divisors to find an estimate. And then we're going to round to the greatest place value to estimate. Here are our vocabulary terms. You don't have to rewrite down quotient, divisor, or dividend, but I want you to read them and review them because they're words that we're going to be using constantly as we talk about division. Compatible number you do need to write down though. A compatible number is a number that can easily be divided using mental math. That's important for this lesson. Here's an example. This example, we're going to use compatible numbers to estimate the quotient. 477 divided by 6. The reason we're using compatible numbers here are because if I rounded 477 to the greatest place value position, I would round it to 500. And 500, you can't use mental math to divide that evenly by 6. So I'm going to use compatible numbers to make it easier. There are two different compatible numbers I could use here, but one of them will give me a closer estimate. So I know that 4, one single digit, cannot be divided by 6. So I'm going to look at both of these digits, and that's why they're underlined in a different color. We're going to look at those underlined digits. This digit to the right of it is going to turn into a 0 because we are still rounding in a way. We're just finding numbers that are easy to divide by 6. So if I'm trying to figure out what number is closest to 47 that 6 will divide into evenly, I think about skip counting by 6s maybe. So I might go 6, 12, 18, 24, 30, 36, 42. 42 is kind of close to 47. Let's keep that one in mind. We'll just write it down over here. 42. 48. Okay, that's another number that's close to 47. So now I'm going to write one of those on top. So we're going to put 48 right here because that is an overestimate, but it's a compatible number we could use. And as I said, I'm going to turn that 7 into a 0. So I just found the number closest to 47 that is divisible by 8. 6 times 8 is 48. Then I'll rewrite my problem and underline my non-zero digits. 48 divided by 6 equals 8. And then I just add my remaining 0 after that. 80. Okay, now let's do the one underneath it. 42 we said was close to 47. And we'll turn that 7 into a 0. It's not underlined. Underline our non-zero digits. 42 divided by 6 is 7. And 400, oh, there we've got to add our 0. We've got a 0 over there, don't we? So the compatible number underneath comes up to 70, and the one above it comes out to 80. One of those will be a closer estimate. Ideally, the one that is closest, whoops, I'm writing all over the place. The one that is closest to 47 should come out as a closer estimate. So which one of these is closer to 47? That's right, 48 is closer to 47. It's 1 away from 47. 42 is 5 away from 47. So it's not nearly as close, and our answer is not going to be as close to the actual answer. So let's do some practice problems. Our first one is 312 divided by 5. A quick note of advice. Check first to see if you can easily round to the greatest place value and if you can divide that number by 5 using mental math. If you can't, then use compatible numbers to solve it. Pause and push play when you're ready. Did you write 60? Let's see how we did that. So first we'll try to round to the greatest place value position. So that would be this 3 here. That's the greatest place value position. And when I round that, I round it to 100. Let's see. 3 is not divisible by 5, but 30 is divisible by 5. Even though that's one of the zeros, I'm going to use that as my underlined number. So I want to make sure I keep it underlined so that I know not to add that as a 0 later. 30 divided by 5 is 6. 6 times 5 is 30. Now I just have 1 0 left over to add on there. So 300 divided by 5 is 60. Number 2, 256 divided by 3. Try it several different ways. See what you come up with. Then push play when you're ready to check your answer. Did you write 90 or 80 or 100? These are all acceptable estimates. Let's see how we figured those out. We found that this was true in multiplication too, that when we estimated, we came up with different answers from the person sitting next to us. As long as we're using the correct strategies, that's okay. Estimating isn't an exact answer. There are several close estimates, or sometimes only the closest estimate. But this time, you had several to choose from that would be good estimates. If you were rounding to the greatest place value, so you would be rounding to the hundreds place, you would round to 300. If I underline the 30, because I usually look at both those digits there, and I underline the 3, 30 divided by 3 is 10. I'm going to underline those so I don't get that confused with my remaining zeros. Now I have 1 0 to add to that. You could have just underlined the 3 and done 3 divided by 3 is 1. That would work too, and then add 2 zeros. Your answer is going to be the same. But now we can also use compatible numbers. What's the closest number to 25 that's divisible by 3? Well, 24 is really close to 25, and 3 times 8 is 24. We're going to turn this 6 into a 0. So 24 divided by 3 is 8, and we'll add our 0 onto the end. But 27 is also divisible by 3, and it's closer to 25 than 30 is. So let's try 27. Add a 0 there, turn that 6 into a 0. 27 divided by 3 is 9, and we add that remaining 0. Now, how do we know which one of those is the closest estimate? 27 is 2 away from 25. 30 is 5 away from 25. And 24 is just 1 away from 25. That would make us lean towards this one. The actual answer is 85 remainder, oops, let's do remainders because that's what we do in 5th grade. Remainder 1. So, because this is halfway, but just a little bit more, it's actually closer to 90. So 90 would be the closest estimate. But any of these estimates are good estimates and will work. Here's another one of my favorite vampires, the Count from Sesame Street. Remember how he used to count all the bats and go, ha, ha, ha. I can't even imitate him, but it was really fun to watch him. Here's our third question. The Count is catching bats. He has caught 610 bats. If he wants to put about 7 bats in each cage, approximately, that's kind of the same as saying about, approximately how many cages will he need for all of his bats? Use compatible numbers to find the closest estimate. Go ahead and figure this out in your journal and then push play when you're ready. Did you estimate about 90 cages? Let's see how we got that. So we know we're using compatible numbers this time. If we rounded 610 to the greatest place value position, it would be 600, and 60 divided by 7 doesn't divide evenly. So we're looking for a number that is close to 61 that can be divided evenly by 7. That means there would be no remainders if you divided it like a regular division problem. So I know that 7 times 9 is 63. And remember, I can always skip count to figure out which numbers are actually multiples of 7 here. So there's my 63, and I don't have to turn that into a 0. It's already a 0. On this side of it, 7 times 8, which is 1 under 7 times 9, is 56. And I'll turn that into a 0, which it already is. So if I'm dividing 63 divided by 7, that's 9, because 9 times 7 is 63, and I add my 0. Then I come down here and work this problem. 56 divided by 7 equals 8, and I'll add my 0 onto the end. Now, if I'm trying to figure out which of these estimates is going to be closer, there are 2 in between 61 and 63. 63 minus 61 is 2. And here there are 5 in between 61 and 56. 61 minus 56 is 5. So it looks like this would be a closer estimate. If we look at the actual answer, it's 87, remainder 1. 87 is closer to 90, so this is our closest estimate. Either estimate, though, would be close and would be acceptable. It's time to challenge yourself. I love this problem. Count Dracula is buying a box of toothbrushes for himself and his 8 friends. They all want their teeth to be sparkling white. Each box has 378 toothbrushes in it. About how many toothbrushes will each friend get? Use compatible numbers to come up with the closest estimate. If each of them wants half of their toothbrushes to be red and half to be green, about how many red toothbrushes should be in the box? So you have 2 questions you're answering there. Show your work in your flip journal, have fun with this, and come back tomorrow and check your answer. Finishing up, review your learning goals. This lesson is complex because there isn't just one right answer for a lot of these. There are several correct estimates for each number, for each problem. If you need to go back and practice, do it. If you have very specific questions you need answered, write them down in your journal so I can answer them tomorrow. Also, don't forget to write down, are you at a 1, a 2, or a 3 level in your learning with this? If multiplication is hard for you and your basic multiplication facts are hard for you, dividing is going to be challenging. It is much easier if you know your facts. Did you know you need to be pretty good at multiplying to do this type of division? It's okay with me if you skip count through. And so if you don't know how to skip count, you may want to write that down as a goal for you to learn how to skip count for each number. Creepy Creatures and Castles, you have completed lesson 4-2, Estimating Quotients. I'll see you tomorrow.